right, let's take a look at our lesson on rational root theorem. Okay, so this is our test when everything else doesn't work. I mean, we would not really choose to do this. So I've got this little note here, when all else fails. Now, there are some problems with this, some issues with this that we need to talk about. First of all, the rational root theorem will only find rational roots. Let's remind ourselves what that word means, rational. So it will only find, so rational number, those are integers, which are whole numbers, and fractions. Okay, that's the only kind of roots this will find. So let's remind ourselves also of vocabulary. Zeros is the same as roots, which we've talked about solutions. And we also have talked about x-intercepts. Okay, so yes, this one thing has like 4 different names. Sorry. So this particular test will only find integer roots or integer roots or fractions. That's it. It will not find It won't find imaginaries. It won't find imaginary solutions. It won't find irrational solutions. Irrational would be like, the square root of 3. It will not find those kinds of answers. Okay, we'll only find rational roots. So how do we do this thing? What is it? So some people call it P over Q. If you say P over Q, maybe they'll know you're talking about rational root theorem. I don't know. So P stands for all the factors of the constant term, which if we are in, standard form, if the polynomial is in standard form, it would be the last number. And Q stands for all factors of the leading coefficient. And again, if it's in standard form, this would be the first number. Remember that vocabulary word, leading coefficient, that's the number in front of the variable with the highest power. So those are those definitions. Now what we do to find all the possible rational zeros, which, we're saying here are good guesses. This doesn't, this basically is narrowing down. We have an infinite number of options, right? There's numbers that are, go to infinity, negative infinity to infinity. We have an infinite number of options, but this particular test helps us narrow it down to the only things it could be, the only things that the solutions or roots, zeros, the only rational numbers it could be. And the way we do that is we basically make a fraction of all those possibilities, P over Q, and that gives us all the possible best guesses on how we could find it. And I'll show you this particular technique uses synthetic division quite a bit. And so let's talk about first, how do we find all the possible rational zeros? What do we do? Okay, we want to find, our directions are just to find the possible ones, not to actually solve it, but to just find what is possible. So the constant, or the last, typically if we're in standard form, the last number is P. The leading coefficient, which would be the number in front of the highest exponent, which is in this case the 4th power, this would be Q. And so what we do is we list all the factors of P and Q. So first up, so we look at 15, and all these numbers could be positive or negative, so we need to consider both positive and negative versions. So I kind of like to think of, I love factor trees. We can think of this as like a rainbow. We go 1 times 15 is 15. Let's see, 2 won't go into 15. 3 times 5 is 15. 4, okay, and that's it, those 4. 1, 3, 5, and 15. So those are all of our possible those are our factors of 15. So now let's look at Q. q would be all the plus or minus of, let's see, we've got 1 times 4, which is 4, and then 2 times 2, and that basically gives us all of those. Okay, so here's what we do. We're going to find all of our possibilities by doing a fraction, p over q. So p over q is going to equal plus or minus all of these options. All right, so we take the first number, 1. So 1 over 1, 1 over 2, 1 over 4. So what did I do? I took this 1 and I matched it. I did it 1 over 1, 1 over 2, 1 over 4. Okay, so that, okay, great. That gives me the first 3. Now let's keep going. So look at the 3. So we've got 3 over 1, 3 over 2, and 3 over 4. Okay, so that looks like this. So the 3 over 1, 3 over 2, 3 over 4. See how we take a number in the list of p, the possibilities for p, and we put it in a fraction form over all of the possibilities for q. Now, if we happen to come upon a duplicate, we don't have to write it twice. So far, we have not come upon a duplicate, but it's possible we might. Like, 2 over 2 is the same thing as 1, something like that. We don't have to write that option twice. Okay, so let's take the 5. So we have 5 over 1, 5 over 2, and 5 over 4. Okay, great. Now take the 15, 15 over 1, 15 over 2, and 15 over 4. And so those are all of our possibilities of what could be the roots of g of x. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 positive and 12 negative would give me a total of 12 positive plus 12 negative would give me a total of, what, 24 possible rational roots. Now that's just the technique on how to find what all the possible ones are. In the next example, we're going to actually use this technique to, we're going to do the first thing, find p over q. Then we're going to actually test them out. So let's go to our second page and let's take a look at that. We have one example to work through. Okay, so it's 4th degree. We think about our factoring, things that we would do. So it's got 1, 2, 3, it's got 5 terms. So this would be a candidate for factor by grouping, but I have an odd number of terms, so that just isn't going to work. Factor by grouping only works if we have an even number of terms, because we have to group them, in 2 groups. So that won't work. So this is really, p over q is the only option. So here we go. All right, so values, and actually this is the same problem that we did on the first page. So p over q, I'm just going to copy down those problems. The possibilities, all p over q would be plus or minus. We've got 1, 1/2, 1/4, 3, 3/2, 3/4. Let's write that a little bit better. 3/4, 5, 5/2, 5/4, 15, 15/2, and 15/4. So we already did that work on the previous page. So those are all of our possibilities. So what do we do with those? How are we going to figure this out? This is where synthetic division comes into play. So if you recall, with synthetic division, we first of all have to make sure that all of the exponents are there. I've got a 4, 3, 2, a 1, and a constant. I have everything I need, so I don't need to insert any zeros. So I would write out my the coefficients of each of those terms: 4, -12, 25, negative 14, and negative 15. Okay, great. And so what we would do is we're going to choose one of those numbers, and we just said that there's 24 possible solutions. So we hopefully will get lucky and pick one of them quickly. Let's try 1. Let's try 1. Okay. Remember how we put that number in the box, then we bring the first number down, and then it's just a system of multiplying. 1 times 4 is 4. Then I add down. Negative 12 plus 4 is negative 8. 1 times negative 8 is negative 8. Negative 8 plus 25 is 17. 1 times 17 is 17. 17 plus a negative 14 is 3. And 1 times 3 is 3. And when I add down, I get a negative 12. So for this to work, okay, for this to be considered a root, this number, this remainder must be equal to 0. Okay, has to. So it has to be, so this remainder must be equal to 0 for x equals 1 to be a solution. Remember, solution root 0. So this has to be true. And it's not, so we can, 1 isn't going to work. All right, so let's try negative 1. Okay, here we go. So let's try negative 1. And I'm, again, going to copy down all my coefficients for negative 12, 25, negative 14, negative 15. Draw my line, bring my first number down. Negative 1 times 4 is negative 4. Negative 12 plus a negative 4 is a negative 16. Negative 1 times negative 16 is a positive 16. 16 plus 25 is 41. Ooh, I don't think this is working out very well. Negative 1 plus 41 is negative 41. Oh, there's no way this is going to give me something to turn this to 0. So once I figure out that it's not going to work, I can stop. I don't have to keep going. There's no way that I could get, what I want here is a 0, and there's no way that's going to happen. So, okay, 1 and negative 1 are out. All right, so let's try, just for fun, let's try negative 1/2. I know we like to try to avoid fractions, but sometimes, that's, a fraction is what works. So let's try that out. Let's bring down our 4, negative 12, 25, negative 14, negative 15. So I hope you can see now why this technique is like our last resort. We do not want to go through P over Q if there's another technique, like if we could do factoring or, something else. We would choose anything else over this, but this is what we have. So negative 1/2 times 4 would give me a negative 2. Add down, get negative 14. Negative 1/2 times a negative 14 is a positive 7. 7 plus 25 is 32. Okay. Negative 1/2 times 32 is a negative 16. Add that down, I get a negative 30. Negative 1/2 times a negative 30 is a positive 15. Ooh, I get a 0 here. Yay! Yay! This means that negative 1/2, x equals negative 1/2, is a solution for this particular problem. Whew, great. So now what happens when we find a solution? What do we do then? Well, what we would do is we have a couple of options. The first thing I'm going to do, just so I can show you how this works, if you recall when we used synthetic division before, this last thing was our remainder, right? We have a remainder of 0. Then this next term would be the constant. Then this next number would be the x to the first power. And then this next number would be to the second power. And then we just keep going until we run out of numbers. And this number would be to the third power. So what we have is this particular cubic. Now we have 4 terms. Ooh, we might get lucky. let's see if we can get lucky and like try to factor by grouping. Why not? I mean, otherwise we're going to have to go through this, this scenario, this rational root theorem again. So if we tried, let's see, so we're going to group together the first two and the last two. Okay, so the greatest common factor of the first two terms would be 2x squared. That would leave me 2x minus 7. The greatest common factor in the second two terms is, let's see, 2? And that leaves me 16 minus 15. Oh, that's kind of a bummer. These bubbles. Okay, the bubbles don't match. So I can't do that. That means I have no other choice but to do rational root theorem again. Okay, we can do this. All right, so I'm going to try 3/2. Okay, so now here's the trick here though, guys. So once we have eliminated or basically gotten one of the solutions, instead of going back to my original numbers right here, I'm going to use my new numbers. I'm going to use these. These are the ones that I'm going to use. I'll put those in green. So this is what I'm going to use right here, the new numbers. I'm not going to go back to the old ones because I've narrowed it down. I'm done with the old ones. I've already gotten one solution or one root out of the old numbers. Now we're going to use the new ones because it's trying to reduce our work. Okay, so let's try this. Bring the 4 down. Okay, so 3/2 times 4. Let's see, 2 goes into 4. 2 times 3 is 6. So negative 14 plus 6 is negative 8. 3/2 times a negative 8. Let's see, 2 goes into negative 8. Negative 4 times 3 is negative 12. Okay, that brings down a 20. 3/2 times 20. All right, 2 goes into 20. 10 times 3 is 30. Oh, yay! Yay, we got another 0. So that means x equals 3/2 is a solution to our polynomial. Okay, great. I got negative 1/2 and 3/2. So now I for sure can ditch p over q because what I'm down to is a quadratic. This last number is the constant. The number in front is to the first power. The number in front of that is to the second power. And so what I'm going to do is I'm going to set my quadratic equal to 0, and then I can, goodness, what can I do? I can do quadratic formula. I can do complete the square. First of all, I don't want to work with these big numbers anymore. I'm going to factor out the common factor here, which is a 4. So 4 times x squared minus 2x plus 5. Okay, and I divide the 4 off. Let's see, that is not factorable. So it looks like I'm going to need to do quadratic formula or completing the square. So I do quadratic formula, negative b, negative 2 is 2, plus or minus, square root of b squared minus 4 times a times c, all over 2 times a. Okay, and so I will just go to that answer. We simplify that formula, and we should get 1 plus or minus 2i. Whew, so I have this as an answer. 1 plus or minus 2i, I've got x equals 3/2 and x equals negative 1/2. And so that finishes up our lesson on rational root theorem or p over q.